Hello, my amazing students. This is Mrs. A, and this is going to be 5.1 homework help. I hope that you have as much fun with this assignment as I am, because I'm really getting down to trying to figure out all these formulas and make sure by verification that they are the same, and they are. It's really cool. So I'm going to show you number 7. So number 7 says genetic disorder, 5 males with an X-linked genetic disorder have one child each. The random variable X is the number of children among the 5 who inherit the X-linked genetic disorder. So here's our information right there. And what I did is I decided to do this on my calculator and just play around with it and do the mean and standard deviation on the calculator. I'm going to show you how I did that just so that you're more familiar with your calculator and what it does. Okay, so I started out with making a board, and then after I did 3 of the rows, I said, you know what, I'm going to go to my calculator. So I had started with an X column and a probability of X column, and then I did this one on my calculator. I'm going to show you what I did. So when I go over here to my calculator, I'm going to go to, let me see if I can hold it and hold my, all right, so here is my calculator, and I'm going to go to Stat Edit. So I went to Stat and Edit, and I'm going to right now go up to L5. You can see how many things I've got in here. I was playing around with it. So in my L1 column, I put my 0, 1, 2, 3, 4. So it's 0 through 5 is each one of the options, okay? And then in my L2, oops, I don't know why I just graphed that. Sorry about that. All right, so in my L2, I have all of those probabilities, and I just entered those in one at a time. So I have my X value in my L1, and I have my probability value in L2. So then I decided to do the rest of this with my calculator. So what I did, and this is fun to do, it takes a little bit of time, so you might not want to do it on a test, but for homework, it does help you to understand your calculator better, and you slowly get faster at this. So here's L3. So I'm going to make L3 the product of L1 and L2. And the way that I do that is I come up to L3. So you see my cursor's all the way up in the L3 slot. And I'm going to say second and then L1 times second, and then the 2 down here will give me my L2. So I'm pressing the 2, and notice what it says. It says L3 is now L1 times L2. So then when I hit enter down here, then it's going to calculate all of these, which is the product. And so 2 times 0.313 is 0.626. Okay, so now I do have my product here. And so here's my product, and my product between the two, X times probability of X, is in my L3 column. Now, I have to add those up, which isn't that big a deal when you only have 6 things to add up. But suppose you had 30 things to add up. So when I have something like this in my calculator, I can do a one variable stat on the L3 column. So that's what I'm going to do. I'm going to go to Stat, and then instead of Edit, I'm going to go to Calculate. I'm going to choose a one variable stat, but instead of that blinking light saying, where do you want me to do the one variable stat on, I'm going to do second L3 here. So I'm going to hit the 3 button, and that's going to have them do the one variable stats on L3. So now I hit Enter, and guess what I get? I get the sum of all of the things that are in L3. Okay, so when I did that, I get the sum of all of the things that are in column L3, which were each one of these. So I find that my sum is 2.5, and remember 2.5 is the mean for this problem. So down there at the bottom, I have them summed up to 2.5, and I got that straight off of my calculator. So then I started trying to say, okay, now what do I want to do with my variance squared? And what I wanted to do, and I did, is I wanted to do both of these formulas for you. So remember, over here on page 189, it gives you two different ways to get the variance. Okay, now we don't want the variance, we want the sigma, we want the standard deviation, but we have a variance formula that says that this is the one easier to understand. Sorry about that. And then we have a variance formula that says this is the easiest one to calculate manually. So I had never done both of them at the same time, so I wanted to compare them, and they are indeed equivalent. So this is how I did that on my calculator. Okay, so I have both of the formulas here, and I put the top formula in the L4 column, and I put most of the next formula in the L5 column and did the calculations that way. So what I did here is I went to the L4 column, so I'm going to go back to Stat and then Edit, and then I'm going to go to the L4 column. I'm going to go up to the top, and I put the formula in here. So I want the formula, since the mean is 2.5, I want the formula here to say L1 minus 2.5 quantity squared times L2. And then I want to add them all up. So I'm going to do that. I'm going to say L4, and then I'm going to start entering them in. I'm going to say second L1. Let's see if I can move this back a little bit. Okay, so I'm going to put L1 and then minus 2.5, and I should have put a parenthesis, so I'm going to have to go back, put a parenthesis, and then an L1, and then a minus 2.5, which is the mean, parenthesis, and then don't I want that L1 minus mean squared. So I'm going to put the parenthesis, I'm going to do this little caret over here and square it. Okay, so I've got that in there, and then what's the rest of the formula? Times the probability. Well, my probability is in L2, so I'm just going to say times the probability, which is in L2, and now don't I have one column of that done? So then I'm going to hit enter, and then all of my L4s are going to calculate. Okay, so basically what I've calculated is each individual in this string, and now I'm going to sum them together. And again, I can sum them by doing a, let me move this down, that's why it's so, okay. So by doing a stat edit again, a stat calc, so I'm going to go across to calc. I'm going to do a one variable stat, but this time I'm going to do it in L4. So second 4, and that gives me my L4. So one variable stats in L4, and again, it's going to sum everything that I have in the L4 column, and the sum is my variance. So now what I have is 1.246 is my variance. So here is my board here. And since I didn't want to write them all down there, I wrote up at the top of the variance, I wrote the variance that I'd gotten from my calculator. I took the square root of that, and I get 1.116. So that was doing it with one way of calculating the variance. So, and then of course, inquiring minds need to know, I wanted to do it using the other formula and say, are these indeed going to give me the same answer no matter which formula I use? So now, remember this was done in L4. Now I'm going to go and do this one the same way, but I'm going to do that in L5. And on this one, I've got to sum all of these together and then just minus mean squared one time. So we're going to do that. I'm going to multiply all, I'm going to put these in L5. I'm going to do a one variable stat, add them all together, and then I'm going to subtract the mean squared and see if I get the same variance, which of course would give me the same standard deviation. So here we go. Okay, well they said this one's a little bit easier for calculations. So this is what I put in. I put my L1 squared times L2, which is my probability, remember, is an L2, and that's going to give me my L1, which is my random variable x, L1 squared times L2, and then I've got to sum them all up together, and after I sum them, I've got to subtract mean squared. So now I'm going to, since L5, I'm going to enter that. So L5 is what I just put in there. So now I'm going to do a one variable stats on L5. So that's going to be stat calc one variable stats on L5. Second 5 is L5. And so now I should find the sum. The sum is 7.496. So 7.496 I have on my board over here. And here's my board again, juggling everything. 7.496 minus mean squared. And remember, the mean was 2.5, so mean squared is 6.25. When I subtract that, I get the variance is 1.246, which is exactly what I had before using the other formula. I took the square root of that, got 1.116, just like I did before. And I verified to myself that the two equations are indeed identical. And I feel just a little bit smarter than I was earlier today. And at my age, it's always nice to feel a little bit smarter than you were when you got up this morning. Okay, so that was a really long explanation of how they got the mean on 7 to be 2.5 and the standard deviation to be 1.5. But sometimes you just have to go the extra mile and understand things a lot better. So it was a probability distribution because the sum of all of those original probabilities over there added up to 1. All of these add up to 1, so it was a probability distribution. So we were supposed to go ahead and find the mean and the standard deviation, which we did. All right, the next one we're going to do is number 9, which I thought was cute. Ted is not particularly creative. He uses the pickup line, if I could rearrange the alphabet, I'd put you and I together. The random variable x is the number of women Ted approaches before encountering one who acts positively. All right, so these are his probabilities. 1, 2, 3, 4. He's got 0.001, 0.009, 0.030, 0.06. So, I mean, he's not really batting 1,000 with this line, so I don't know why he keeps on using it. But if you add these up, if you are looking for whether it's a probability distribution or not, all of these should add up to 1. And there's no way that they're going to add up to 1. So this is not even a probability distribution. Ted just needs help. Okay, so over here's the answer. It says this is not a probability distribution because the sum of the probabilities is 0.1, not 1, which is not the one as required. The probabilities show that Ted needs work. I thought that one was really cute. So that was number 9. Okay, so this is problem 15 in the book, and I've got it set up on the whiteboard. Guess what? I found some whiteboard cleaner. I had to go begging for it, but I got some whiteboard cleaner. So our boards are all clean. And this is the information for problem number 15. And this is the number of girls in this birth problem here. So we're doing number 15. It says find the mean and standard deviation for the number of girls in 8 births. Okay, and there's our table there, and I just have put the table on the board. So now you can see at the top of the table, I've put x times probability of x, and then down at the bottom, I've got the little summation symbol. I'm going to have to do all of that. And then, remember in the last problem, the one that we started with, I did the variance 2 ways. This was the more easily calculated way, and remember I did it 2 ways on my calculator, and I found out that this one gives you exact same variance as the other one, but then we don't want the variance, we want the standard deviation. So I'm going to have to do that and then take the square root of it to get that one. So here I'm going to work a little bit and then I'm going to come back and show you. Okay, now you know me, I'm all about not doing more work than I have to. So when I scroll up, I did very little to this thing since the last problem I did. Okay, my L1 is now been extended from 5 items to 8 items. So all I did was add a couple more of those. The L2 was where I had my probabilities, so I had to put in the new probabilities here. So I copied those off of the chart. And then, remember before when I had done the problem, L3 was the product of the two. And I have not changed L3. So I'm going to just go up and I'm going to do it again because I need to extend that on down. And so what I'm going to do is I'm going to reassign L3 to be the product of these so that then I can put that in my X times probability slot. Okay, let me see if I can get this to shine a little bit better so you have a little bit more light on my screen. Okay, so there it is. Now I'm going to say L3. Notice I have my cursor up in the L3 slot up here. So now I'm going to set that as L1 times L2. So I do my second and my 1 to get L1 times, and I just use my times sign, and my second L2. And then I enter, and now that recalculates my L3 to be the product of them all. So now I'm going to take all of these here and I'm going to go over to the board and I'm going to write them in the slot that is X times P of X. Okay, so now this is what I have, and now I'm going to move on and add those all up together because the sum of those gives me the mean. The sum of the X times the P of X column is going to give me the mean, and I'm going to do that on my calculator because I've got this column in my third row, my L3 on my calculator. So I'm going to do a 1 variable stat on my L3 column. Okay, so I'm going to go to stat, calculate, and I'm going to do a 1 variable stat. So I'm going to hit enter, and I'm going to tell it to do it on, I don't know why it says answer to 1 variable stat. So let's clear that out. Let's try again. Stat and calculate and 1 variable stats. Now it looks like it's supposed to. And notice that it's blinking to say, hey, which column do you want to do the 1 variable stats on? Because I want to add up column 3, I'm going to say L3 here. So second 3 gives me L3. Then I'm going to hit enter. And now this summation of X is going to be the summation of the L3 column, and that should be my mean. So 3.996. Okay, so I put my sum down here, but remember, when we're talking about how many significant digits we can only have one more significant digit than the number of that we have in our random variable X, and we have integers in our random variable X, so that this one can only be 1 decimal place, so we would have to say 4.0 is the mean. Okay, so we have 4.0 is the mean, and that is the answer in your book. And now I'm going to have to go up to the top and start that calculation right there to get the variance. Okay, so I've rewritten my formula here. This is my sigma squared, which is my variance. Okay, and so I have to take x squared times p of x, which means I'm going to do this on my calculator, I really don't want to have to take each individual x value and square it and then multiply by the probability and then add them all up together and then subtract the mu squared. So I'm going to show you how to do this on the calculator to make it faster. Okay, so I'm going to go up to the L5 cursor and I'm just going to, well, I could do L4. We'll go to L4 since we're not using L4 for anything else. And I'm going to take that x squared times probability of x and just put it in there. So we'll say L4, and then down here you're going to see what I'm going to write in here. I'm going to put second L1 because that's where my x squared is, or my x is, and then I'm going to have to square that, okay, and then I'm going to multiply it times L2, which is where my probability is. So that's what my formula should look like, and that's going to give me my x value squared times my probability, which is what I want in the parentheses there. So now I'm going to hit enter, and I'm going to get my L4 is going to have that in it, and I'm going to write that on my board. Okay, so this is what my board looks like now. I've got my sigma squared, which is my variance, and notice that I put the little little brackets there to show you that that's what this column is right here. And now I have to sum that all together, and I'm going to do that using my calculator because I don't want to enter them all again. So I'm going to do a one variable stats on my L4 because that's what I have that data in. So here's my calculator again. I'm going to do a stat calculate and a one variable stat. And it's blinking here saying, which column do you want to do one variable stats on? I want to do it on L4, so I'm going to do second 4, and that tells it L4. I'm going to hit enter. And this sum here is the sum of column L4, which is 17.98. Now that's my variance, not my standard deviation. That sum is going to be my variance. No, I take that back. I have to take that and subtract the mean squared from it before I get my variance. My bad. So 17.98. Okay, so to clarify, remember this was what my column was. And when I did the one variable stats, I got the sum. Okay, so I put the sum down there, 17.98. But notice that my formula tells me now to get my variance, I need to subtract the mean squared. And the mean was 4.0. So the mean squared is going to be 16. And so I'm going to subtract right down there 16. And remember, I can only have one decimal place accuracy there. So minus 16.0, which is going to give me 1.98. So I've got sigma squared is 1.98. And then I have to take the square root of that to get my sigma. So sigma is going to be the square root of 1.98. And when I do that, I get a standard deviation of 1.4. So to recap, after all that, we had a mean of 4.0. We had a standard deviation of 1.4. And that is correct according to your answer key. So I'm going to zoom out so you can see the whole board together and see what I did. I did most of the calculations on the calculator because I'm all about doing calculations easily. So over here, I put this in my L1. I put my probability in my L2. I set my L3 to be x times the probability, and I put that formula in there, and then it calculated it for me. I used a one variable stats on L3 to get this sum. The sum is my mean, but I can only have one degree of accuracy there after the decimal, and that's your rounding rules. Then I came over here and I'm using the easier to calculate formula for my variance. I let this column be this little part here, x squared times p of x, and again I did that in my calculator. I used L4 for that. Okay, I used, instead of summing it by hand, I did a one variable analysis on this one variable stats, and that gave me the sum of the whole column was 17.98. Then I subtracted the mean squared, which was 4 squared, which was 16. I got my sigma squared, which is my variance, is 1.98 when I did that math, and then I took the square root to get 1.4, and there you have it. That was problem 15. Okay, now we're doing problem number 17, and it's so nice that we don't have to recalculate mean and standard deviation for this one, because now we're trying to use that range rule of thumb to determine whether 6 girls out of 8 girls would be unusual or significantly unusual. So we already know the mean is 4, and we know the standard deviation is 1.4. So all we have to do is see what is going to be the range of mean plus 2 standard deviations, mean minus 2 standard deviations, and see if 6 is inside that range or if it's on the edges. All right, so this is all I had to do. Mean plus 2 standard deviations was 4 plus 2 times 1.4, and mean minus 2 standard deviations is 4 minus 2 times 1.4. I can't calculate those out, and I've got a normal expectation of 1.2 to 6.8. So 6 girls is not unusual because it's inside this region. It's not over here, it's not over there, it's in between. Therefore, that is not significant. It is not unusual. And right there is the answer so that you can see it. Significantly high numbers of girls are greater than or equal to mean mu plus 2 sigma, and mu plus 2 sigma is 4, plus 2 times 1.4 is 6.8. Okay, so the normal range goes all the way up to 6.8 because 6 girls is not greater than or equal to 6.8. It is not significantly high number of girls. All right, so now we're doing number 19, using probabilities for significant events. A, find the probability of getting exactly 6 girls in 8 births. Find the probability of getting 6 or more girls in 8 births. Find the probability, which probability is relevant for determining whether 6 is a significantly high number of births in 8 births. The result from part A or part B. Is 6 a significantly high number of girls in 8 births? Why or why not? We already know that answer, but now they're breaking it. Instead of using the range rule of thumb, we're getting a little bit more nitty-gritty about this whole thing, okay? So we're really answering the same question that we did in 17, but we're doing it in pieces and thinking about it a little bit more. All right, so A in this problem says, what's the probability of exactly 6 girls? Well, looking over on our chart, we have, this is the probability chart, right? 6 girls would be column 1, and probability of 6 girls would be column 2. So we're going to look right across, and lo and behold, the probability of exactly 6 girls is 0.109. So right here, we will write 0.109. Okay, and then the next one says the probability of 6 or more girls, which would be the probability of 6 or 7 or 8 girls. So we're going to look over here and we're going to add those all up together. So when I add 0.109 and 0.031 and 0.004, I'm going to get 10 plus 4, 14, carry, and I'm going to get a 4. And then I don't carry, and I get a 1, and I get a 0.114. So 0.144, excuse me, 0.144. Okay, so when we're talking about the 6 or more girls being a significant number, that means that it's rare. And we would look at this number B because this is the total probability of 6 or 7 or 8 girls, which is what we're really trying to find. 0.144 So we're going to use the B number here. And then we're going to say, no, it is not significant because 0.144 is not below 5%, which is kind of our mark, okay? Remember, 95% of all of your data is in between the -2 and the +2 standard deviations. So there's a total of 5% outside of there. This is 0.144, which is bigger than the 0.05. So no, that would not be significant using probabilities. So that was that problem there, number 19, I believe. There is problem 19's answer in the book. All right, I think this is our last one. I'm going to go back and check, but I'm pretty sure. Number 27, expected value in Virginia's Pick 3 game. In Virginia's Pick 3 lottery game, you can pay $1 to select a 3-digit number from 000 through 999. If you select the same sequence of digits that are drawn, you win and collect 500. Well, basically, you have to select the same 3-digit number. So it's only one number that you're picking. So for every pick, you have, since there are, how many different selections are possible? Well, from 000 to 999, that's going to be 1,000 picks, 1,000 different numbers that are in there. So the answer to A should be 1,000. For B, it says, what is the probability of winning? Since you're only going to win if you get one of those numbers, the same number, it's going to be 1 out of 1,000 is your probability of winning. And then C says, if you do win, what is your net profit? And that would be, if you win, okay, you paid $1 for the ticket, and they said if you win, you collect $500. So 500 take away $1 is $499. And then D says, what is your expected value? So when we have the expected value, we're going to take the probability that we lose times the -1 plus the probability that we win times the 499. And when we calculate that, here's our equation down here. We got, since we have 1 out of 1,000 chances to win, we have 999 out of 1,000 chances to lose $1. So we multiply the 999 divided by 1,000 times the -1, and we add that to the 499, which is what we would win, times the 1 over 1,000. And when we do that math, we get -500 over 1,000, which is -0.5, or -50 cents on the dollar. Every time we pay $1, we can expect to lose -50 cents. And of course that is on average. So if we played this thing 500 times, we would expect to lose 500 times 50 cents or $250. So remember that expected value is really your mean of what's going on. So the last one says, if you bet $1 in Virginia's Pick 4 game and expected value is -50 cents, which bet is better in the sense of producing a higher expected value? A $1 bet in the Virginia Pick 3 game or a $1 bet in the Virginia Pick 4 game? In order to do this one, we really have to look at problem number 26. And problem number 26 is talking about a Pick 4 lottery. So we've got to learn a little bit about what the Pick 4 lottery is. And it says in the Ohio Pick 4 lottery, you can bet $1 by selecting 4 digits, each between 0 and 9 inclusive. If the same 4 numbers are drawn in the same order, you win and collect $5,000. Okay, how many different selections were possible? Okay, on this one, I'm just going to give you the answers, because what happened is on this one you ended up getting expected value of -50 cents also. So basically this one is -50 cent expected value, and the one that we're doing down here is -50 cent expected value. So what your book is saying is the answer is that since they're both bets have the same expected value of -50 cents, neither bet is better than the other. So I'm going to show you the answers for 26 and 27, since you really kind of had to do 26 in order to get 27 right, that last little part. So the answers to 26 are right here. 10,000 is the possible number of selections made. 1 out of 10,000 is the probability of winning. Your net profit was 4,999, and then you're basically going to have the expected value calculated very much the same. You get -50 cent expected value. Okay, so those were the answers to the problem 26. And then for the last part of 27, which here are the answers for 27, for that last part, they're saying because both bets have the same expected value of 50 cents, -50 cents, neither bet is better than the other, because they both have the same expected value. So I hope you're finding this helpful, and we will be back with 5.2 in a little bit. This is Mrs. A, and may God bless your day.